are going to enjoy this talk. So please give a warm Starmus Earth welcome to Kip Thorne and Lia Halloran.
Hello, everyone. Thank you so much for that wonderful, warm welcome. We're super excited to be back here at Starmus, and we want to give a special thank you to Garrick and ESET and the wonderful team at Starmus who's done a fantastic job organizing us.
Our universe is varied and vast. Galaxies, planets, stars, and moons, quasars, pulsars, and magnetars, all made from atoms and molecules, just like you and me, and all that we hear and touch and see. Our universe is also endowed with a marvelous shadowy side that is warped. Phenomena forged from warped space-time. Witness the ravenous fat black hole that Lia here depicts, ingesting her wife, Felicia.
Although this warp side is entwined in the weft of our matter-filled universe, its stars, its planets, its nebulae, its galaxies, and its comets, we humans never saw it until just recently. Why did we never see? Warped space-time cannot produce light or other signals that yesterday's technology was able to perceive. So now, how has that changed? We humans have made our first contact with the warp side of our universe, using gravitational waves, ripples in the shapes of space arriving from a space-time storm very far away and very long ago. The ripples were captured by LIGO, the Laser Interferometer Gravitational Wave Observatory. To this we shall return. The warp side of our universe is home to many beasts that are forged from warped space and time, beasts that may well include black holes and wormholes, time machines and cosmic strings, gravity waves and singularities, our universe's Big Bang birth, and many other beasts, wondrous, weird, and wild.
For decades, I, a beast, materially composed, have been consumed by quests to fully comprehend this warped side of our universe. How? Through tricks of mathematics and computer simulations, probing Albert Einstein's relativity equations. And in a 1,000-person fleet of scientists and engineers, we've pursued a quest to invent, construct, and utilize our behemoth LIGO for humans' first encounters with the warp side of our universe.
Big questions have driven these warp side quests, some that I'm sure you've asked yourself, and some you likely have not. How did our universe begin? Can anything travel backwards in time? How does warped space-time behave when wildly, frenziedly writhing like the open sea in a storm? How does the warp side of our universe impact the material side, the side that we humans see and feel?
In an artistic, poetic book that Lia and I have created, she and I use paintings and verse to shed some glimmers of light on all of these big questions.
So what we've just finished presenting to you is a portion of the prologue of our book. Our collaboration was 13 years in the making and was initially started as a short article for Playboy magazine. That's a whole other story. We'll tell you at the star party later. So through many conversations, and I made over 660 paintings, our book grew into 240 pages, which was carefully distilled into poetic verse as an integrated vehicle for communicating the essence of science to non-scientists. The project was born out of a desire to create a non-didactic book that both gives an elegant experience of the universe, but also presents some of the latest theories and discoveries, many of which have not been written about widely. So Kip and I set out to make a book that we, the two of us, would love to read about the strangeness of the universe and present it in a very intimate way that invited a wide audience to experience the essence of the warp side of our universe.
In the rest of our presentation today, we'll use paintings and verse to describe some things that are not in our book and are not well known outside of a circle of specialists. These things are discoveries about the amazing roles played in our universe of the stuff that is left when you have removed everything from the universe that can be removed. The remaining stuff is called quantum fluctuations of the vacuum, since a vacuum is the ultimate form of nothingness. We will see how these vacuum fluctuations, by sucking energy out of expanding space, likely produced everything that we see around us in our universe. And we'll tell you in paintings and verse how these cosmological discoveries have motivated a new 21st century technology called quantum precision measurement that will likely play a powerful role for humanity over the coming few decades. But first, we'll lay some foundations for this by describing a few things that are in our book about black holes and gravitational waves that propagate through the universe, bringing us information about what's far away.
First, we shall lightly explore the quintessential example of a beast who inhabits the warp side of our universe, the black hole. In 1920s and 30s, when black holes first emerged from equations of relativity, Einstein didn't believe. They were far too bizarre for belief. But now we know that Einstein was wrong. Among the stars of our universe, quintillions of black holes are sprinkled, and millions inhabit our galaxy, our Milky Way, our home. The black holes are all hidden from view. They emit no light whatsoever. Nevertheless, they make themselves known when their gravity tugs on stars and on planets, gases, and galaxies.
A black hole is made from space that is warped. What space is warped, you may very well ask? Nothing less than all of the space of the universe in which we live, the space of all our activities with three familiar dimensions, east and west, north and south, up and down. What is the way space is warped, you might ask? The measurable distance across a black hole is tremendously large. The measurable distance around a black hole is very much smaller. If space were flat, that could not be. The space of our whole universe may be warped in a larger space with higher dimensions, 4 or 5 or 10 or more, dimensions that humans never can see, dimensions we physicists call the bulk. How can we visualize this warping in Lia Halloran's dazzling paintings? We pretend that the space of our whole universe has just 2 dimensions instead of 3. This space she depicts as a stretched rubber sheet, a membrane or brain in physicists' argot, a brain that resides in the bulk. As viewed by creatures who live in the bulk beings I shall call them, our brain near the hole bends down like a funnel, making huge the distance across the black hole, the distance we measure inside of our brain, the distance traversing the funnel's surface, inward, then downward, back up, and then out. Like everything else that we humans conceive, Felicia, Lia's fabulous wife, resides with us inside of our brain. As bulk beings watch, gravity drags her along the brain surface, then into the funnel, and downward toward the funnel's tip, a vicious and lethal tip. It is the black hole's chaotic singularity. We also reside inside of that brain, though far from the hole where the brain's flattened out. We see Felicia by light rays that cruise inside of the brain and not through the bulk. So we in the brain cannot see the funnel. Instead, as the hole ingests poor Felicia, staring with light rays, we see her legs vanish into a yawning black spherical hole.
A black hole is made from time that is warped. Einstein's law of time warps asserts things like to live where they age the most slowly, and gravity pulls them there. The slower is the aging, the stronger will be the gravity. The gravity near a black hole's mouth is unbelievably strong and arises inexorably from enormous slowing of time. If Felicia hovers near the mouth of the hole for only a single hour, when safely returning home, she'd find 1,000,000 years on Earth have passed. You and I and Kip have long since died, and Earth has changed unimaginably. At the lip of the black hole's mouth, time slows down to a stop, so gravity there is boundlessly strong. Nothing there can escape its grip. Whatever is drawn past the lip of the mouth forever is lost from our universe. So the lip of the mouth is a black hole horizon into which we can never see unless we too plunge through the lip with return and impossibility.
A black hole is made from vortices of rapidly twisting space. Just as Earth spins around its poles, so also a black hole rotates. The hole's rotation makes space around it swirl like air inside a tornado. And just as the swirling air drags all the tornado can catch, cats and cows and cars and clocks, so also a black hole swirl drags everything nearby into a whirl around the hole, fast near the hole's horizon, languid far away. As Felicia, aghast, falls feet first into the spin of the black hole's north pole, her feet nearer the hole than her head get dragged around more strongly, so her lovely body gets twisted. Her eyes see her feet turn clockwise, and her feet see her head turn clockwise, so the swirl near the hole's north pole comprises a clockwise vortex of twisting space bound to the hole's horizon. On the other side, the south pole side of the rapidly spinning black hole, a counterclockwise vortex of rapidly twisting space bound to the hole's horizon twists all that passes through.
What is Felicia? She's the sum of all her parts. Her face, her silken hair, her arms and breasts, her hands and legs and feet, her heart, her brain, her precious personality. And what is a black hole? It's the sum of all its parts. Its space that is warped, the funnel of bulk being seized, its vortices of whirling space, its tendencies that stretch and squeeze, its slowing time and down cascading time, its horizon and its singularities, all made from warped space-time.
Warped space-time in a storm and gravitational waves. A very long time ago, 1 billion years in the past, while here on Earth, multi-celled life arose and spread around the globe. In a galaxy far, far away, 2 spinning black holes danced around one another, rippling the fabric of space and time. The ripples, the gravity waves, sucked energy from the hole's orbit, so the holes spiraled inward, eclipsing each other towards a climactic collision. The holes, at half of light speed, catastrophically collided and merged in a brief cataclysmic storm of writhing and twisting space-time that brought the waves to crescendo. The climaxing gravity waves from this catastrophic collision surged out of their birthing galaxy and into interstellar space. Spreading across our universe for nearly 1 billion years, they stretched and they squeezed all that they met, stars and planets and nebulae, in patterns that encoded a portrait of their birth, colliding holes and space-time storm. Then, 50,000 years ago, when humans shared Earth with Neanderthals, the spreading and weakening gravity waves sailed into our spiral-armed Milky Way, our galaxy, our home.
On September 14th of 2015, near the Antarctic peninsular tip, the waves flying upward plunged into the Earth through air and then oceans, then rock, whispering up through Earth's bowels unscathed and emerging just north of New Orleans. The gravity waves came face to face with a complex and huge L-shaped invention designed and built to perceive them. LIGO. Flowing through LIGO, the gravity waves stretched and then squeezed microscopically 2 very long beams of bouncing light that extracted the portraits the waves had encoded, colliding holes and space-time storm. This tiny shudder in LIGO was momentous for the whole human race, our very first moment of contact with the warped side of our universe. The laws of physics dictate that only 2 types of waves can travel across our universe, bringing us portraits of far, far away. We humans have long known the first of these, electromagnetic waves, light rays and X-rays and gamma rays, radio waves, and infrared. Einstein predicted the second type, gravitational waves comprising tendencies that stretch and squeeze all that they pass through. It was Galileo Galilei, 400 years ago, who built an optical telescope and, pointing it to the sky, discovered Jupiter's 4 large moons, thereby creating instrument-based electromagnetic astronomy.
Over the past quarter century, LIGO's human fleet, 1,000 physicists and engineers, constructed their 2 behemoths. Upon turning them on in 2015, they discovered the waves from colliding black holes, and thereby they birthed instrument-based gravity wave astronomy. Contemplate the revolution in how we view our universe, the revolution wrought by electromagnetic astronomy over the past 4 centuries and 20 human generations since Galileo's time. This may foretell, indeed, a radical new revolution that gravity wave astronomy and electromagnetic entwined will bring to our descendants over the next 4 centuries. A revolution transformational like the one Galileo wrought.
Now, at last, we turn to vacuum fluctuations in our universe. Imagine a box filled with nothing. All has been removed from the box that possibly can be removed. Only a vacuum remains. This vacuum smolders, so saith the quantum physics laws, with infinitesimal fluctuations of everything that ever could reside inside the box. Electric fields and forces, magnetic fields and forces, gravity fields and forces, cats and cars and cows and clocks, with very tiny probabilities, flash into surreal existence ever so very briefly, and then flash out. These vacuum fluctuations, forever irremovable, pervade the warp side of our universe and feed the warp side in powerful ways. We humans first learned about this from my dear Russian friend, Yakov Zeldovich, whose insights were truly amazing. Zeldovich already was famous for designing the Russian hydrogen bomb in the era when Russia was panicked with fear of an American nuclear strike. In September of 1973, in the giant Hotel Rossiya on the banks of the Moscow River, Zeldovich and his student, Alexei Starobinsky, revealed to Stephen Hawking and me a remarkable discovery that Zeldovich had guessed and Starobinsky had proved mathematically using the laws of physics.
Imagine a spinning black hole, they said, surrounded by nothing but vacuum. The black hole is bathed from all sides in roiling vacuum fluctuations. Of everything that could ever reside in our universe, I here depict those vacuum fluctuations bathing the hole from the left, though they really bathe from all directions at once. The vacuum fluctuations feed voraciously off the hole's vortices of rapidly twisting space. By suctioning energy out of the twists, the fluctuations transform themselves into real particles of everything that ever could reside in our universe, ejected rightward, forming a beam of quantum radiation.
Hawking and I were amazed, and Hawking, a more profound thinker than I, flew home to England deep in thought. How else might a vacuum fluctuation feed off a lonely black hole? After 3 months of struggling with this, in December 1973, Hawking had an epiphany that radically transformed how physicists view black holes.
Imagine a spherical star, a star that has no spin, imploding to form a black hole, as I here depict in blue. The black hole is born in the star's central core, and as the star shrinks, the black hole grows larger until it has swallowed the star. The warped space-time of the rapidly growing hole harbors enormous energy. Incoming vacuum fluctuations suction up that energy from the rapidly growing hole as they skim along its horizon, transforming themselves into particles of everything that ever could reside in our universe. These particles, close to the hole's horizon, struggle to escape the black hole's growing grip. Some escape quite quickly, while others, nearer the hole's horizon, escape rather more slowly, and others, nearer still, require a day to emerge, or a month, or a year, or a century, but ultimately emerged unscathed as Hawking radiation. The black hole, even 1 million years later, is ejecting Hawking radiation, extremely weak, but inexorably there, forcing the hole to shrink, and ultimately, a gazillion years later, to explode and disappear. An explosion triggered by ancient vacuum fluctuations of everything that ever could reside in our universe.
Our universe was born in a Big Bang singularity, whose quantum gravity core created space, created time, and created all the primordial stuff from which everything in the universe emerged and evolved and ultimately morphed into the patterns we see. In the early 1970s, there emerged from Zeldovich's fertile mind another powerful speculation. Perhaps, he guessed, the Big Bang singularity did not directly produce all the stuff in our universe. Perhaps, he speculated, the singularity produced something far more simple, just vacuum fluctuations of everything that ever could reside in our universe. And perhaps those fluctuations, with voracious appetites, fed off the enormous energy of our universe's expanding space. Perhaps this feeding endowed the vacuum fluctuations with just the right total energy to perfectly transform themselves into all the matter and all of the radiation that fill our universe today. The matter from which all the stars were born, and the galaxies and the planets, and the Earth and all its people. A few years later, Zeldovich's younger colleagues used the quantum laws of physics and Einstein's laws of warped space-time to prove him probably right. Starobinsky, Linde, and Guth made real Zeldovich's dream in their theory of cosmic inflation.
So today we know with rather high confidence that the warp side of our universe uses vacuum fluctuations in truly amazing ways, not only in the Big Bang to give birth to all that we see, and not only in all black holes to give birth to Hawking radiation and every hole's explosive death, but also perhaps in wormholes where vacuum fluctuations suitably manipulated can hold a wormhole open, enabling interstellar travel by civilizations highly advanced, as in Christopher Nolan's interstellar science fiction film. And also perhaps in time machines, where the moment a machine is turned on, vacuum fluctuations begin to travel through, and piling on top of themselves, piling up in space and time, create a gigantic explosion that destroys the time machine, thereby keeping the universe safe from all attempts to go backwards in time and alter history.
Quantum measurement technology. Now that we know how powerfully the universe employs its vacuum fluctuations, can we humans also invent powerful ways to manipulate the vacuum fluctuations for our own technological needs? Absolutely yes. Vacuum fluctuations are a powerful foundation for 21st century quantum measurement technology, a technological cousin of quantum computing and quantum cryptography. That quantum measurement technology, now in its early infancy, was birthed by LIGO physicists as a tool with which to probe the warp side of our universe.
In each of the two LIGO arms, a light beam is trapped between free-hanging mirrors weighing 40 kilos. Here we see one of the mirrors hanging in a cradle. And here, looking down from above, we see all 4 of the mirrors. When an incoming wave tickles the L, its tendencies stretch the east-pointing arm, pulling the mirrors apart, and stretching the light beam they trap. And its tendencies squeeze the north-pointing arm, pushing the mirrors together, and squeezing the beam that they trap ever so minusculely, 1,000th the width of a proton. 10 milliseconds later, the stretch becomes a squeeze, and the squeeze becomes a stretch. By alternating stretch and squeeze, the waves tap out their message and inscribe it on the beam, colliding holes and space-time storm in which the waves were born so very far and very long ago. The light beam trapped in each arm leaks out through its corner mirror. The 2 leaking beams interfere inside of a photodetector, translating their stretch and squeeze code into electrical voltage, recorded at last for humans to see, colliding holes and space-time storm.
This LIGO behemoth is plagued by two different species of quantum noise, each inexorable, each irremovable. The first quantum noise is a jiggle of each of LIGO's four mirrors, a jiggling motion ever so slight, 1/billionth the width of each atom of which the mirrors are made, a jiggle demanded by the quantum physics laws. How amazing it is that LIGO can see human-sized objects, its mirrors, behaving quantum mechanically. LIGO's second quantum noise is a tiny quantum fluttering of the light beam that carries the gravity wave signal to the photodetector. If not wisely controlled by quantum measurement technology, these two quantum noises, the mirror jiggling and light beam fluttering, would hide the gravity wave signals that LIGO successfully sees today.
In 1968, 56 years ago, another Russian physicist, Vladimir Berginsky, warned us of the dangers of these quantum mechanical issues. In 1981, 43 years ago, Carlton Caves, a brilliant Caltech student of Kip's, identified a solution. Both quantum noises, Caves discovered, arise from a single source, vacuum fluctuations of light. Entering our behemoth from the direction of its photodetector, these vacuum fluctuations beating against the laser light cause the output beam to flutter quantum mechanically. And through their pressure of each of LIGO's mirrors, drive the mirrors jiggling. And so Caves quickly concluded both quantum noises can be controlled by manipulating the fluctuations that enter LIGO's behemoth. By wise manipulations, we can send the noises into irrelevant nooks and crannies where they do no harm to LIGO.
Caves, a brilliant student, identified specific manipulations that would do the job. Before the vacuum fluctuations plunge their way into LIGO, change their quantum state, he said. Squeeze horizontally each tiny blob as it fluctuates into and out of existence, and squeeze vertically the largest blobs, and the medium blobs squeeze at a slant. Thanks to insights from Bill Unruh, a friend of Caves in Vancouver, it became crystal clear that this squeezing can make LIGO's gravity wave measurements immune to both quantum noises. Caltech's H. Jeff Kimball, whose lab was down the hall from Caves, invented the apparatus that squeezes the vacuum fluctuations in precisely the wave Caves specified. And over the next 40 years, LIGO's physicists and engineers perfected the squeeze technology and installed it into LIGO. This very first example of quantum measurement technology is crucial to LIGO today. It's a key to LIGO seeing several collisions of black holes each week, far out into the marvelous warped side of our universe. And it's just the tiny beginning of the powerful new technology for quantum precision measurement. And we thank you.
Thank you.